Video, we're going to talk about inscribed and circumscribed polygons within a circle, as well as tangent lines. A polygon is inscribed in a circle if all of the vertices lie on the circle. So in this example, the pentagon is inscribed in the circle. A polygon is circumscribed about a circle if each side is tangent to the circle. So in this example, the square is circumscribed about the circle. You'll notice that I've drawn the points of tangency for each side of my square. We know that the sum of all angles in a quadrilateral equals 360 degrees. Opposite angles sum equals 180 degrees in an inscribed quadrilateral. So in this example, I have an inscribed quadrilateral. The opposite angles add up to 180. Tangent lines intersect a circle at one point, and this is called the point of tangency. You'll see that I've drawn a radius to that point of tangency. The radius and our tangent line, so a radius drawn to a point of tangency, creates perpendicular lines with the tangent line. So keeping that in mind, we are given that segment AC and BC are tangent to circle O. Based off this information, we have the point of tangency A and B. We know that angle A is a 90-degree angle as well as angle B. Now, let's say that I drop a line in here. So and it's a shared side. All right. Well, let's start naming some sides. So let's call this side, we'll call it X. All right. And then let's call this side here Y. And now notice I call this radius Z. Well, the radius of a circle, or all the radians of a circle, are congruent. So I can also call this radius Z because they are the same measurement. So what I've formed here is two right triangles, and what we know about right triangles is Pythagorean theorem. So I know that this side squared plus this side squared will equal my hypotenuse squared. So what that means for our example is that Z squared plus Y squared equals X squared. And that's for this top triangle. Well, now for the bottom triangle, once again, Z squared, which I get from this radius, plus, and we'll call this side E, side E. So Z squared plus E squared equals, once again, that hypotenuse, which is a shared side, X squared. Now, notice both of these are set equal to X squared, so I could set them equal to each other. Which then notice that Z squared exists in both of them, so if I were to, say, subtract Z squared from both sides, they would end up canceling each other out, and what this tells me is that Y squared is equal to E squared. And really all that this shows us, using this Pythagorean theorem, are that the segment BC and segment AC are congruent. And so if I have two tangent lines that are drawn or tangent to a circle at certain points, that they are congruent. And so what we did is we proved that segment AC is congruent to segment BC. Alright, so now let's look at some examples. So our first example here, first off, let's assume that all lines that appear to be tangent are in fact tangent. Well, from this, just what we discussed is that these two sides are congruent. So I'm going to set them equal to each other and then solve for X. And since there's no quadratics here, I don't have to worry about factoring. I'm simply going to get my variables on one side and my numbers on the other. In this situation, I get X is equal to 8. Now, our next example, we have this tangent line. Well, what we know about tangent lines are that they form a 90-degree angle at the point of tangency. Well, notice that I have a radius of an unknown length. Well, this radius here will also be an x. And so what this tells us is I have x, and so what I'm going to use here is Pythagorean theorem, so x squared plus 15 squared equals my hypotenuse squared. Well, in this situation, my hypotenuse is x plus 9, so an unknown value for the radius plus 9 squared. So in order to solve this, what I need to do is first simplify everything out. So x squared remains x squared, 15 squared is 225, and then I'm going to FOIL this binomial out and get x squared plus 9x plus 9x plus 81. My 9x's combine, and I get 18x plus 81. And now what I'm going to do is I'm going to begin to solve. So first off, let's subtract x squared on both sides, and we see that they cancel. And so now what I would like to do is get my x's on one side and my numbers on the other. So x already remains by itself on the right-hand side, so let's subtract 81. Alright, and I'm going to have a moment where I need a calculator. No shame in it. So 225 minus 81, 144, and then 144 divided by 18 would give me a value of 8. So we're going to be able to use what we know about inscribed and circumscribed polygons to solve for expressions, as well as what we know about tangents to solve for different expressions. Thanks for watching.